Good morning, everyone. My name is Uddesh Soman, and welcome to the AI Club. Today, we are going through a couple of demos, coding demos. First one, we'll see Spacy basic demo. What are the features in Spacy and how we can use uh, natural language processing model, the pre-trained models from Spacy. Next up, we'll have a look at NLTK GenSim, uh, Spacy NLTK and GenSim. So we will first go through a couple of Spacy features and then we'll see the GenSim one. So
You have to zoom
first
a
of
bit, so much. You have
yeah,
to zoom a bit, yeah.
yes, sir, sure. So first of all, starting with our Spacy demo. Spacy is simple. We can just call the import. Then we have to load models. So there are a couple of models. So you'll have to download these models separately. Uh, Once you have downloaded these models, you can call the spacy.load. So one of the models is EN Core Web SM. So we'll be doing our text processing using this model. So first of all, we have to create a doc object. How to create a doc object? We just pass our string in the NLP. Here we have defined this model as NLP. So we'll pass our string into this model and we'll
Just
receive
a
a doc
second.
object.
Someone, just a second. I want to add. When we say spacy.load, en underscore core underscore web underscore sm. So we are downloading a particular version of kind of English dictionary. So a kind of English dictionary which is built in Spacy. So underscore SM, web underscore SM is one type. So we are downloading. There are a couple of more types. Maybe some long or short dictionary might be available. So that we need to look into. So this is the way we are downloading a particular type of dictionary, English language dictionary using Spacy. Yeah. Yes.
So yeah, after we have passed our statement through our Spacy model or dictionary as I said, we get this doc object. So from this doc object, we can extract tokens. What are the separate tokens that Spacy has identified? So these are the tokens in our sentence. Microsoft is trying to buy France startup at 7 million at $7 million. So it creates separate tokens. After that, we can see those tokens. We'll have to call token.text. So each token object, we can derive particular properties. Token underscore POS. So already because POS tagging is included within that Spacy model. I'll show you the pipeline of this. So this kind, there is a pipeline within this Spacy model. Yeah, this kind of pipeline exists in Spacy model. So there is token to vec. So it is
Need
actually
to zoom a bit.
yeah,
Yeah.
yeah.
So
Token
this.
to vec. These are the parts of Spacy model of proper pipeline. So we have token to vec that converts token to vectorizer, so or tokenizes simply. Tagger, that is a simple POS tagger. Next is parser, so it finds dependencies within sentences, which noun, which verb is related, and all those kind of dependencies. Attribute ruler, so any attribute relations, any sentence relation, any text-based relations are found using attribute ruler. There is lematizer and the final NER, the name entity recognition. That is the last one. So these are the components of our model. So let me show. Yeah. So all the processes that we have seen in NLP so far, all the syntactic, semantic, lexical analysis, all that is done within the model itself. So um, this one is an example of tokenization. We just called the text of token. Here we can call the part of speech of the token. So we can see part of speeches, this Microsoft prop noun, auxiliary verb, again part verb, proper noun, all that. Next up is chunking. So chunking we have seen in previous class is basically grouping together same kind of objects. Or so here we'll see an example of grouping together noun chunks. So the sentence here is Tesla is automobile based endorsed with high tech work for implementing electric cars. So we can simply the sentence through our model. We get this object, doc object, and from this doc object we call noun chunks. And when we print the chunks, we get this Tesla, automobile, high tech work, the electric car. So these are the identified noun chunks. Maybe depending on the model or depending on how it understands your text, there might be some phrases that might not be noun text, noun chunks still added, but the more or less accuracy is good. So we get noun chunks. Similarly, we can go for other kind of chunks as well. We have to call.
So can we see NERs in this?
Yeah, we'll see later on.
Yeah.
Just go with the demonstration. Yeah. Next up is Displacy. Displacy is a built-in feature within Spacy. So from Spacy, we can import Displacy. It creates these kind of displays. See all the dependencies, all the attribute relations we can see using Displacy. So Displacy, we call Displacy render, or we pass our model, or we pass our doc object from we call style Jupyter true, because in order to show options, this is actually pixel based option, the size mentioned on. So
Just a second, someone just stay on this particular thing. So
yeah,
I want to add that here, just note down the smaller dependencies. So since build is dependent, Tesla is dependent on build. So what kind of dependency is this ADVCL? So this is coded dependency. And I shown you one model, one particular document while teaching yesterday's class. If you open that document, particular document, they are decoded. What is the meaning of ADVCL? What is the meaning of AUCL? What is the meaning of DOBJ? So this kind of dependencies are decoded there. So you can see that Tesla is dependent on build is dependent on to. So these kind of relationship, word dependencies are automatically generated by Spacy in just one command. So you saw that tokenization and chunking and dependencies, everything is generated by just one command of Spacy. So it is very easy to use.
yeah. So in order to see all kind of dependencies, only this much code is needed. Just call the dependency render, pass the your doc object, and style Jupyter is equal to true in order to show it in uh, as an output here, like we did in matplotlib inline. So these are kind of just this much code is enough, and sir has already explained how we see the dependencies and how we visualize them, and we have also seen that in our theory session. Next up, we have matcher. So in case we have phrases that might be similar, that we can add to a matcher object and check in our doc object. So like here we have an example of this solar power. So you can see there are multiple strings. Solar power, this is one string. Solar dash power and solar space power. Now the thing is, for a computer, these three are three different strings. Even though we know that all three strings are similar, for the computer, these three are three different strings. So in order for pattern matching, in order to make sure that these three are treated as same, we need to specify that this is a pattern, and we can all these three mean the same. So here call the matcher. Matcher is also built within the Spacy. It's Spacy library. We call the matcher, and we call matcher with NLP vocab. So whatever our model is, we uh, pass all the vocabulary from that model. Now we create various patterns. So patterns are created in this way: dictionary within the list. So each list contains a dictionary, and the dictionary actually corresponds to our string. So solar solar power. This is one. These are just tags for it. So keys you can ignore. Keys can be anything, but yeah, lower means for which means the given string in lowercase. That is simple. That's it. Again, if you want to see this pattern, solar dash power. So solar second character is punctuation. So is punctuation true? We just marked it as true. We do not have to specify which punctuation. Low again, lower means in lowercase power. Next, again third pattern, solar dash power. So we pass two separate dictionaries with lower key, lower solar and lower power. So these that's how we create patterns. We add these patterns. So these three patterns, pattern one, pattern two, and pattern three, they all correspond to solar power. So what is the main word or one of the phrases we can select to say that all these patterns are related and a list of patterns. So we have created all three patterns here. We pass them together as a single list. We add it to our matcher objects. We just call the add method, add it to our matcher, and then you can see if we take all this, we call the match we call the matcher on our doc object. So whatever the text is, we pass it through our
No, just a second, someone. Sorry for interruption. So in
yeah,
the text, please note that solar power is written in a different way. So
yeah,
solar dash power, then in second line at the end it is written solar power combinedly, and then in third line it is written solar dash power. So all of these three things which are separated. So dash it is taken as a punctuation, and in pattern two we have defined that between solar and power there is a punctuation. Is punctuation true?
yeah.
So dash is taken as any punctuation. So here any punctuation you can specify, it will take up. And these three different type of patterns. So when we match, then it treats them as same as solar power, and then it will tell you the position of from what is the start and what is the end of that particular pattern. So first solar power is starting with 1 and ending with 3, and second is starting with 25, 26. So is it start or what? Yeah. So see
Yes,
what
sir.
1 and 3,
Those
1
are
and 3 is
indexes.
what?
One and three are indexes, starting and ending index.
Starting and ending index of what?
Whoa, that particular pattern.
So it is not matching, na? Solar power is the bigger one, right?
Solar power. So solar starts
Starting
from
with 1 and
index
ending
one
with,
and two. Actually, it includes the next index as well. Like
so which one is next index?
that solar one, power two. So up to power, then it will index the plus one index also. Include the
No,
plus
no,
one
see,
index
1
also.
belongs to S, right here. 1 belongs to S. And 3
Sir,
belongs to what?
this is not string. It is for token actually. That
It is
separate
for,
token
okay, it is taken for
means
token.
yeah, not this string means not one, two, three, four, five, not this string, but token. So this is token number one, token number two, like that.
Okay. So from
Yeah.
token 1 to 2 is taken as 1 comma 3.
Yeah, so means three means because last index is not included, so maybe it is built-in feature because in every iteration, like all other string matching operations, I have seen it includes the plus one token, means plus one index also.
So then it should start from 0, right?
Uh, it, I think it is one based indexing. That's why because one is included in all of these.
Can you print the token for this particular thing? Is it possible to print all the
Uh,
tokens for this particular sentence? Is it
yeah,
easy right now?
yes, sir.
So NLP text you have done. So just create one more cell and print. Just create one more cell. Just create one more cell. Now one more cell you create below this, and yeah, so you just create one more cell and print all the tokens. So I want to verify what is 1 and what is 3.
Yeah, is it case sensitive? Because S and P are uppercase.
No, sir, because we already specified here, na, it takes in lowercase. So in any way, NLP by default converts it all in lowercase and then does all the processing. So capital, those uppercase words won't matter.
Okay, so maybe solar can be capital, SO can be capital. It doesn't matter for it because it is lowercase, no?
Yeah.
Okay.
If you see here, we have defined solar power as whole in lowercase, but still it is able to identify this, no? Solar power with S and P in uppercase.
Yeah. Okay.
Just print the tokens. I want to verify the. Just so I want to verify. Just copy that code. Yeah. So
Wait. It's actually stuck in that one.
yeah. So maybe
Wait.
you have to maybe you can now put it at text
Yeah.
one, second one.
Yeah, this
So
one.
solar is the first token,
Solar is first
second
token, power is
token,
second.
and like that you have to count till 25 if you want to verify that 25 and 26.
Yes.
So just see like
Wait a minute.
I comma, yeah, very nice.
तो
Yeah, so
टोकन डॉट इंडेक्स
first,
ऐसा कुछ नहीं है टोकन डॉट
Okay.
इंडेक्स ऐसा कुछ अवेलेबल नहीं है
Hmm?
you have to define a separate variable I. Is there nothing available like token dot index or something like that?
No, sir, I don't think it is available. I think I'll have to check the documentation for the thing.
it is
For the
starting wrongly from 2. It is starting wrongly from
start
2. It
starting
should
from
start
two, I
from
think
1, na? So
I think space is also included. That's why.
no space, you cannot take any token, na? Yeah. So you start with 0, let us see. I is equal to 0. Why it is leaving this? So I think we have to do some kind of
But
R&D here.
actually,
So
this
okay.
the string is perfect. I think this much space it has also.
No, yeah, space it won't take. No, let's try. Space it won't take.
Yeah,
Yeah,
sir, it was because of the space. There was space in the
yeah. So
starting
now
of
put
string.
it I equal to 1, then it will be correct. No, here, yeah, I equal to 1.
No, now, sir, the code has changed. No? Our output has changed. It's from now it's from 0 to
0.
2 instead of
Yeah,
1 to
yeah,
3.
yeah, yeah. So that is the thing.
Yes,
And
still
note
the
down the index of second one. 24, 25, what is there?
24, 25, it is the solar power.
Just see, no?
So yeah,
24,
it's on
yeah.
24 and also including the next index plus one
Yeah,
index.
sir, 24. Yeah, and let's check the other one. The other one.
This solar dash power. So this is 32 to 34. It should be 32 to 35.
Yeah,
Yeah,
very
32
nice.
to
Yeah,
35.
yeah. So we could decode it. Yeah. Okay, good.
Yeah. Next up, we this. So again, we if you want to get the ID, so
Yeah, this
yeah,
job we
sir,
have
you asked.
already done actually.
I sir, you asked for the IDs, right? So this one is the part.
Yeah, this we have already seen now. So we can go
Wo-
ahead here.
We can just call NLP vocab and strings, and we call for their IDs. So from the found matches object, This was found matches of the matcher object, means return of the matcher object, and from that we call the match ID using a loop, and we get doc start to end. So this basically we call a span. Span is actually a part of the sentence. Like instead of whole this sentence, if we want to give a part of sentence, we call this uh, match ID, this span. So it's simple like we do in a simple list or a tuple. The same we can do here, start index, end index, and because in Python the end index is not considered. Uh, the very last element till end index is considered and end index is excluded. That's why the last index is also included. This strings will actually change because we have made the change. Yeah. So see, we can call the match ID. Match ID is actually some kind of ID it generates for the matches. String ID. So whatever string that has matched, because all this we have given as a single string, solar power. All these patterns correspond to solar power. So the match is for solar power here. Match is for solar power. The starting index means where it was found. The starting index, ending index. So actually end of string plus ones. So that end is also included in Python indexing. And which string was found, whatever the text was found. So from that span, we extract text. So solar power, this was the string found at 0, 2. At 24 to 25 solar power, this concatenated string. And this one separated by hyphen. So this is how we actually find matches. Next up, we this is actually finding the information about all the that POS information, part of speech
POS tagging
information.
is done here, yeah.
Yeah, POS tagging plus we can the tags with their information. So like here we pass the sentence: the quick brown fox snatched the piece of cube from mouth of black crow. So again we just pass it through our NLP model. We pass it through our model. We get the doc object and we take tokens out of it. So token.text. So whatever the text is in the token, part of speech, will get the part of speech. The tags for that. So whatever the tags there are for that part of speech, and then we explain those tags also. We explain those tags, what the meaning of that particular tag. So because sometimes we are confused with this abbreviations, na DTJJ. Sometimes we are confused with this abbreviation. So their explanation as well. So the is determiner, then its tag is DT, and explanation determiner. Quick English adjective, brown English adjective, fox noun singular. This comma, punctuation mark, comma again. So we have it for the whole sentence. Each and every sentence, what is the tag, what is the meaning of tag, what is the explanation of that word. So like the thing that we did for name entity recognition. In name entity recognition, we were identifying whether something was a person or group or a country, like that. Here we are doing the same, but for grammatical part. We are identifying what part of grammar it is, what is the grammatical explanation of that particular word. That we can do here by calling all these.
Yes, Soman, you can even show that what is NLP. So NLP is the what object where we had instantiated Spacy. So you can show once more because people forget, no? So it's a long thing, so people don't remember. Yeah.
NLP
So
is
this
simply
is
a
the default model we had loaded into NLP object. So same thing we are using, and in single command we are getting all our things done. So everything is done in a single command. So once you have NLP object, you have default Spacy model loaded in NLP object, and you have now Spacy model in form of NLP object. So that is where you are, everywhere you are using same single command to get your things done in a single command. So it is damn easy actually to use this. Theory itself is theory only is long, but coding you see is Damn simple. So yeah, go ahead. Yeah.
Yeah.
So NER is not there with
Again,
us. NER.
NR is actually here.
NER is there.
NER will get into the next demo as well. This one
Okay.
actually
Okay.
corresponds just a small part of it.
Okay. Anyway, NER we can see in the next demo, right?
Yeah. So next up, if we want POS counts, what are the part of speech counts? So just count. We call this method count by on our doc object. So doc object is the output of NLP after we pass our sentence through the NLP. NLP contains our NLP is object for our Spacy model, pre-trained model. We haven't done any training. The model is pre-trained. We just extracted it, named it NLP. We pass any sentence through that. We'll get the doc object as a result. So this doc object we call the count by method. And count by what? So count by part of speech. So Spacy
Someone, you can
ATTRS.
show once again how you got the doc object. So you just show once again whatever you explained.
Yeah.
So
So
yeah.
earlier we have seen that our model is actually we loaded our model and termed it as NLP. So NLP actually is our model, pre-trained Spacy model. Now all we have to do is pass any sentence, any string through that NLP model. It will do all the processing, all the 5 parts that I have told you. This is the NLP pipeline. So 6 processes. These all 6 processes will happen, and after that, what we'll get as a result will be this doc object. This is actually a doc object, and from this doc object, we call all the methods. Uh, we can get our tokens, part of speech, and all that. We are calling on this doc object. Yeah, here we go. So this one actually is just a code to find the POS count. So so what is the count of each part of speech? So here POS counts, dog count by Spacy. Count by what? So count by POS. So we'll have to pass the POS object. So POS object is within Spacy, Spacy ATTRS POS. This is the part of speech object. We pass it to count by method, and we call this count by method on doc object. So if we part, the result is actually dictionary of this form. So whatever these are certain tags for part of speech, and whatever with the count. So whatever it is at 90, it's count 2. At 92, its count is 5. So if we call the text, what is the vocabulary for that 92, whatever that 92 represents, we pass that into vocabulary and see its text. Then we can see 92 refers to noun. So any part of speech that is noun, it is represented by 92 in that vocabulary. In its vocabulary, the Spacy model's vocabulary, it is represented by 92. And the count of noun, how many noun part of speeches are there in our sentence? So that is 5. Yeah. So that was a way to count the part of speeches. Next up, other if we want other settings for display, we have seen the display. We have seen a display demo where we actually call all the dependencies and part of speeches of our sentences. Here we have seen this was the default setting and default display of all the dependencies. If you want to change or view it in a different format, let me get here. So this is what we can do. Distance means how many pixels we want to set. Compact means if you want to compact it or words or arrows should be closer to each other. So that is to color what color we want. So this is actually in the form of that hexadecimal code, the color hexadecimal representation of the color. Background, so background color selected. Font is actually in font is stated as Arial font. And whatever the option we select, we just create a dictionary out of all those options, and we pass it into this options parameter within the display render, and it can do it for it will create the display accordingly. If you want any change settings, if you want any change settings and colors, you can actually go here, Google, Google Color Picker. You can select any color from here. Most of the colors are available, and here you will see the hexadecimal code of it. Just copy it from here, and in your options you can actually put the color as the hexadecimal code.
Put that new option. Let us see what happens. Whatever you have
Yeah.
done, the selected color, just put that option. Particular option.
Yeah. See, I've selected a different color, and the color changed.
Yeah. So
Get a different color. It's actually.
So you need some kind of lighter color, actually, yellowish or those kind of things.
Yeah, I'm just.
Or the original itself was better.
Yeah.
Yeah, this is very decent.
Just go to Google Color Picker and have any color you want and copy the hexadecimal code. And that hexadecimal code can be passed to the color as well as background. Font, we can select any available font. So here by default, Arial is selected. We can select any other font as well. So all this we put it in our options dictionary, and we pass it to the options parameter. And once we call the method with this options parameter, we'll get a different display. Otherwise, the default display is good as well. This one is the default display. Okay, so now moving on, the thing we were waiting for, named entity recognition. So the process remains same. We pass any sentence through our model, and the model is declared in NLP, declared as NLP, and we get the doc object as return. Next, we print entity label. The label actually tells us what is the label for that entity, what is the named entity that is recognized. Explain the entity label. So explanation of entity label. So we can get the explanation of that label, what that label means, by calling explain entity label. So here in this sentence, Ambani good to go at Gujarat, start an agro-based industry in Geomart for $70 million. So Ambani is identified as a person, and its explanation is people, including fictional. Next up is Geomart. Geomart is recognized as organization, so company, agency, or institution, etc. $70 million, money, monetary value, including unit. So this is named entity recognition done using Spacy model, Spacy pre-trained model. And if you want to visualize it in a good manner, so we again call displacy. We pass our object through it. Here we pass this display again. We call displacy render. Pass our sentence. Pass our doc object. We have to keep the style as ENT. ENT means entity. So in order to display entity, again Jupyter is equal to, and then we get this. All our entities all our entities are actually highlighted with their entities, means entity labels. So Ambani person, Geomart organization, $70 million money. So that's how name entity recognition is done using Spacy model, any Spacy model. So this one was a basic Spacy demo. I'll be moving into the next demo. So far, if anyone has any questions or any part of code that you want me to repeat, I'll go through it again. Otherwise, we'll move to the next demo.
Yeah, so thanks, Soman, for a wonderful demo, as usual. So I think this was a very basic Spacy demo, and it demonstrated you major Spacy commands, like how to use Spacy for doing different things that we learned, like POS tagging, NER, finding, doing NER, then you want to do chunking, then you want to do kind of relationship identification between words, dependencies between the words. So all this we had learned in our theory session. So this was a simple demonstration with a simple document, like simple sentences we had taken and demonstrated all the Spacy commands, how to use it. So this was not a complete example, or it was not, we cannot term it as a complete NLP analysis. It was just a Spacy demo. And how to use it is very obvious that these demos, you can use it in whenever you do your NLP, a complete NLP or analysis in your projects. So you can use this command to your advantage and do the desired kind of NLP analysis. So whatever we had learned, so POS tagging is being done here in just one command. Then we do NER is being done in just one command. We saw how to do chunking. That also we saw. Then we saw how to do relationship mapping. So these are the things which measure which were output for syntactic analysis and semantic analysis. So everything is being demonstrated with the help of Spacy. So after that, what we'll do is that this was the Spacy model. So whatever tags were used in NER and POS tagging, so all tags were built in into Spacy. So that's what we have used. So we use default Spacy model without any training. So default Spacy model we just instantiated with the English object, like a particular version of English we have instantiated, and we used it NLP. Okay, so that's how you used it. So next is suppose you are using for a specific domain, Spacy, like medical domain or defense domain, or say any other very typical domain for which POS tags and NER and entities are not built up in Spacy. For that, you need to first train the Spacy model in the labeled corpus. So you have to first label the corpus. So say medical corpus. So suppose medical transcript is written, so you have to take the complete medical transcript and label it. So entity and POS tagging you have to do with hand tagging you have to do. So you have to find out POS tags with the help of hand, write POS tag manually. You have to write entities manually. So like that you have to write, and then train your Spacy model so that next when Spacy encounters any unknown any unknown paragraph or any unknown document which is in medical domain, so your trained model can find out POS tags and entities for that particular domain. So that's how we need to use Spacy. So this is one standard demo with the standard Spacy model. So next next example we will see how to train a Spacy model in a particular domain, and then use it to our advantage whenever we encounter a unknown passage or unknown document. Okay. So thanks.